Hi students, good morning. In the last class, see the problem. If fifth term of q by 2x minus px whole power 8 is 1120 and p plus q is 5 and p is greater than q, then the value of p is. This is the problem. See the solution. That what is the given expression? Given that the expression is q by 2x minus px whole to the power of 8. In that expression, fifth term, if the fifth term of this expression is 1120, that is given, and also we have to given t5, that is the fifth term is given 1120, and p plus q is 5, and p plus q is 5, and p is greater than q. Then we have to find the value of p. What is fifth term? That fifth term is written as t4 plus 1, that is 1120. So what is the term here? T5, the term, t5th term is what is the here? NCR, that is 8CR. R is here 4. The first term is q by 2x whole power 8 minus 4 into second term minus px whole to the power of 4, that is 1120. Okay, now we are simplifying this one. Okay, here this is 8c4 into what is here? Q 8 minus 4, that is 4, q to the power of 4 by 2 to the power of 4 into x to the power of 4. Here minus 1 whole power 4, that is even term, we are getting plus. Here p power 4 into x to the power of 4, that is 1120. Here x power 4 is cancelled. Okay, so next we are writing 8c4. What is 8c4? That is 8 into 7 into 6 into 5 by 4 factorial, 4 into 3 into 2 into 1. Here PQ, P power 4, Q power 4, that is PQ whole to the power of 4 by here 2 to the power of 4 is equal to 1120. Here, what is here 2 3s are 6, 6 will be cancelled. Here 4 2s are, that is 2 into 5, that is 10, this 0 will be cancelled. So here, that is PQ whole to the power of 4 is equal to 111 into 2 to the power of 4, that is 16. Here remaining term in this LHS is 7 by 7. Here 7, 16 are 112. So that is 16 into 16, that is this is 4 square, 4 to the power of 4. Here PQ whole to the power of 4 is equal to 4 to the power of 4. Therefore, PQ is equal to 4. We have to given here P plus Q is 5 and PQ is 4. So then we are writing P minus Q. What is P minus Q? Can be written as root of P plus Q whole square minus 4PQ. So that is the formula: A plus B whole square minus A minus B whole square, that is A minus B whole square is equal to A plus B whole square minus 4PQ. From that A minus B is root of A plus B whole square minus 4AB, that is the formula. So here we are substitute P plus Q and PQ values. What is here P plus Q? That is 5 square, that is 25 minus 4 into PQ, that is 4, that is equal to root of 25 minus 16, that is root 9. Root 9 is 3. So here P minus Q is 3 and P plus Q is equal to 5. Now we are solving these two equations. P plus Q is 5 and P minus Q is 3. P minus Q is equal to 3. Now Q will be cancelled. Here 2P is equal to 8. P is equal to 4. If P is equal to 4, what is Q? 4 minus q is equal to 3. So from that q is equal to, here 4 minus 3 is equal to q. Therefore q is equal to 1. So therefore the value of p, is 4. We are finding the value of p. So that is the required value. That value is p. P is equal to 4. That is the answer. Okay. Okay. See the next problem. The number of terms in the expansion of 2x minus y plus z plus t whole to the power of 5. In that expansion, the total number of terms we have to find. See the solution. What is the given expression? That is 2x minus y plus z plus t to the power of 5. In that, how many terms here? 1, 2, 3, 4. So these are 4 terms. We are taken, number of terms is we are taken 4. What is here n? N is equal to 5. So the total number of terms in R terms, then the formula n plus r minus 1 c r minus 1. That is the formula, the number of terms in that expansion. So the total number of terms, in this expansion is, the formula is n plus r minus 1 c r minus 1. That is equal to, what is here n? N is 5 plus 4 minus 1 c 4 minus 1. That is 9 minus 1, 8 c3. This is the 8c3. That is equal to 8 into 7 into 6 by 3 into 2 into 1. So 8c3, that is 8 into 7 into 6 by 3 into 2 into 1. That is 3 2s are 6. 8 7s are 56. So answer is 56. The total number of terms in that expansion is 56. Okay. So the next problem. The first integral term in the expansion of root 3 plus cube root 2 whole to the power of 9. In that expansion, what is the first integral term? Now I have to find the first integral term of this expression. Okay. See the solution. What is given expression here? Root 3 plus cube root 2 whole to the power of 9. So that is the given expression, root 3 plus cube root 2 whole to the power of 9. In that expansion, we have to find the first integral term. Now we are writing the general term. What is the general term here? T r plus 1. T r plus 1 is equal to, what is here? NCR x to the power of n minus r, a to the power of r. That is the formula. Here n is 9cr into x. X is root 3 whole to the power of 9 minus r into second term cube root 2 whole to the power of r. Now we are writing this one, 9cr, here 3 to the power of 1 by 2 whole power 9 minus r, that is 9 minus r by 2. Here 2 to the power of 1 by 3 into r, that is r by 3. So these are the terms of general term. Tr plus 1 is 9cr. 9cr, that is binomial coefficient, it is integer. Here 3 to the power of 9 minus r by 2 and 2 to the power of r by 3. So if the powers are integers, then this term is integral term. So when the term is integral term, so now this is the 9 minus r by 2 and r by 3 must be integers. When the values of r, these are integers. If you take r is equal to 0, if you take r is equal to 0, this is r 0 by 3, that is integer. Here r 9 minus 0 by 2, that 9 by 2 is not an integer, so it is not taken the r. Next term, we are taken r is equal to 3. If you take 1 by 3, it is not integer. 2, that is 2 by 3, it is not also integer. We are taken r is equal to 3. If r is equal to 3, r by 3, that is 3 by 3 is integer. Here 9 minus 3, that is 6 by 2, that is integer. So in that case, if r is equal to 3, the term is integer. That is the first term of integral term. Okay. Now we are writing which term is the integral term? Tr plus 1. That is the first integral term. That is t. R is here 3. 3 plus 1, that is t4. So here t4, fourth term is the integral. First integral term is fourth term. So it is first integral term. It is first integral term. It is the first integral term. So fourth term is the first integral term for this expansion. Okay. Next problem. The number of terms which are free from radical sign in the expansion of y to the power of 1 by 5 plus x to the power of 1 by 10 whole to the power of 55. So in this expansion, the number of terms which are free from radical sign, that means rational terms. How many number of rational terms in the expansion of the given expression? Okay. See the solution. See that solution. What is the given expression? So that is y to the power of 1 by 5 plus x to the power of 1 by 10 whole to the power of 55. So this is the given expression. Y to the power of 1 by 5 plus x to the power of 1 by 10 whole to the power of 55. So now we are writing the general term for this expression, tr plus 1. What is here? N is 55. Cr, the first term, y to the power of 1 by 5 whole to the power of 55 minus r into the second term, x to the power of 1 by 10 whole to the power of r. So this can be written as 55 cr y to the power of 55 minus r by 5 into x to the power of r into 1 by 10, that is r by 10. So this term is integer term. When the term is integer term, so these powers must be integers, where the terms 55 minus r by 5 and r by 10 must be integers. These are integers. When these are integers, if you take r is equal to 0. If you take r is equal to 0, then 0 by 10, that is divisible. Here 55 minus 0, that is 55 by 5, that is also 55 is divisible by 5. So next, if we take next we are taken 10, r is equal 10. So then only this r by 10 is integer. So now we are taken 10. So here 55 minus 10, that is 45. So 45 is also divisible by 5. Next we are taken 10, 20. Next it is 20, then it is 35. It is also divisible by 5. Okay. Next 30 and 40 and 50. These are all values we are taken. Then 20, that is 35, that is 30, that is 25 by 5, it is divisible, and 40, that is 15 by 5, that is also divisible. 50, we are taken 50, then 55 minus 55 by 5, it is also divisible by 5. So these are the values we are taken. So then after we are taken no one value is divisible by the 10 or 50. So then after we are taken for 60. So what is here? Highest power index is 55. So we are taken r is up to 55. So 51 to 55, anyone is not divisible by 10 and 5. Okay. So we are taking r is 1, 0. 10, 20, 30, 40, 50. These values are only integers for this condition. Okay. So then the number of terms, rational terms in that expansion, we are taken R values are this one. Okay, these are the values 1, 2, 3, 4, 5, 6. These are the number of rational terms. So therefore, the number of rational terms, that is radical sign, free from radical sign, that is nothing but the rational terms. The number of rational terms is equal to 6. That is the number of terms which are free from radical sign. That is the answer is 6. Okay. Next one is the sum of rational terms in the expansion of root 2 plus 3 to the power of 1 by 5 whole to the power of 10. In that expansion, we have to find the sum of the rational terms. First, we have to find the rational terms and adding them. Okay. See the solution. What is the given expression here? That is root 2 plus 3 to the power of 1 by 5 whole to the power of 10. So that is the given expression. Now we have to find the rational terms in that expansion. Okay, now we are writing the general term, that is TR plus 1, that is 10 CR. The first term root 2 whole to the power of 10 minus R into second term 3 to the power of 1 by 5 whole to the power of R, that is equal to 10 CR, here 2 to the power of 1 by 2 into 10 minus R, that is 10 minus R by 2 into 3 to the power of here 1 by 5 into R, that is R by 5. Okay, this term is rational term when these two are must be integers. Here where 10 minus R by 2 and R by 5 must be integers, then only we are getting the rational term. Okay, so what is when R is equal to 0? So that is equal to R is equal to 0, then this is integer, this is also integer. So 10 by 2, that is divisible by 2. Okay, next we are taken R is equal to we are taken 5. If you have taken 5, that is 5 by 5, it is integer, but 10 minus 5 by 2, it is not integer. So then we are taken 10. Okay, so then we are taken 10. Okay, so if we taken 5, it is integer. Then next multiple of 5 is 20. So 20 by 5, 10 by 5, that is divisible. Here 10 minus 10, that is 0 by 2. It is divisible by 2. Okay. Now we are taken, this is the maximum value, that is index is here 10. Okay. These two are the rational terms. Okay. So these are the terms, that is the sum of the terms. Therefore, the sum of the rational terms, rational terms. What are the rational terms here? R is equal to 0, that is T 0 plus 1, T1 plus what is R is equal to 10, that is T11. Okay, so T11, that is equal to what is T1, that is here T0 plus 1, this is T10 plus 1. Okay, now we are writing these terms. So here taken R is equal to 0, that is R is equal to 0, that is 10 C naught, R is equal to 0. So then we are remaining terms are into 2 to the power of what is here 10 minus 0 by 2, that is 5, that is here 10 by 2, that is 5 into 3 to the power of here 0 by 5, 0 by something 0, t power 0 is 1, that is 2 power 5. So what is here 10c naught, 10c naught is 1, that is 2 power 5. Here the remaining next term is what is here t 10 plus 11, that is 10c. What is the here, that is t 10 plus 11, that is r is here 10. So 10c 10 into what is here, the term is 2 to the power of 2 to the power of 10 minus 10, that is 0 by something 0, that is 0. Okay, that will be 0. So 2 power 0 here, and what is here 3 to the power of 3 to the power of here 10 by 5. So this is 10 by 5. Okay, so that value here 10c1 is, this is value is 1, in 2 power 0 is 1, 3 to the power of that is 2, 10 by 5, that is 2. Here what is 32, this is 3 square is 9. So 9 plus 32, that is 41. So this is the sum of the rational terms in that expansion. Okay, another problem. Integral terms in the expansion of fifth root of 3 plus cube root of 7 whole power 36. In that expansion, we have to find the integral terms. Okay, now see the solution. What is the given expression here? Fifth root of 3 plus cube root of 7 whole power 36. So that is the given expression. Now we have to find the integral terms in that expansion. Okay. Now we are writing the general term. What is the general term? TR plus 1 is equal to, so what is the n is here 36. CR, first term is fifth root of 3 whole power 36 minus R. 36 minus R into second term is cube root 7 whole power R. So now this can be written as 36 CR. 36 CR. Here 3 to the power of 1 by 5. 1 by 5 into 36 minus R, that is 3 to the power of 36 minus R by 5 into here 7 to the power of 1 by 3 whole to the power of R, that is 7 to the power of R by 3. So these are the integral terms when these are where this powers 36 minus R by 5 and R by 3 must be an integers. Must be integers. Okay. Now we are what values of R, these two are integers. Now we are verifying that R is equal to, if we take R is equal to 0, then it is integer, but 36 minus 0, that is 36 by 5. So 36 is not divisible by 5. So we are not taken R is equal to 0. So if you take R is equal to 3, it is integer, but 33 by 5 it is not integer. So 5, it is not integer. Then we are taken 6. If R is equal to 6, then it is integer. This term is also integer, that is 30 by 5, that is divisible by 5. Okay, take R is equal to 6. Next one we are observing the taken R is equal to 21 only integer. So 21 by 3 and here also 25 by 5. Then after we are verifying 36 is only possible value. Okay, here 36, that is 36 by 3, that is 12, and here also 36 minus 36 0 by 5, it is also integer. These two are integers. We are taken R is equal to 6, 21, 36. Then the terms, what are the integral terms, that is we are taken. Therefore, what are the terms, integral terms, that is t6 plus 1 and t21 plus 1, that is t36 plus 1, that is the terms t7, t22, T37. These terms are integral terms. These terms are integral terms in the given expansion of this expression. Okay, so what are the integral terms in that expansion is T7, T22, T37. These three are integral terms in the expansion of given expression. Okay, see the another problem. The number of rational terms in the expansion 1 plus root 2 plus cube root to 3 whole to the power of 6. In that there are three terms in that expression. Now we are writing the number of rational terms. See the solution. What is the given expression here? That is 1 plus root 2 plus cube root 3 whole to the power of 6. So this is the expression. It has three terms. So there are r terms. Now see the formula. Now we are saying x1 plus x2 plus x3 and so on xr. If r terms, then what is the general term? We are writing that is n factorial by n1 here p factorial, q factorial, r factorial and so on. That is otherwise we are writing n1, n2, n3. Okay, now we are taken that is n1 factorial, n2 factorial and so on nr factorial into x1 to the power of n1 into x to the power of n2 and so on xr to the power of nr, where n1 plus n2 plus and so on nr is equal to n. So this is the general term for the r terms of the expression x1, x2, x3 and so on xr whole to the power of n. This is the we are taken general term, that is tr plus 1. That is we are taken general term is this one. So here n1 plus n2 and so on nr is nothing but the index n. Okay, now we are writing the general term for this. Now we are writing the general term for this given expression. Okay, now we are writing that is n factorial, that is 6 factorial by here there are only three terms. Now we are taken this is p factorial, q factorial, r factorial. So these are the p plus q plus r is equal to, here p plus q plus r is equal to 6. What are the terms here? 1 to the power of, here p we are taken, that is here n1 is powering, okay, x1 to the power of n1. Here we are writing p factorial, the first term to the power of p, and second term, that is what is second term? Root 2. Root 2 is nothing but 2 to the power of 1 by 2 whole power q, that is q by 2. So then next third term is 3 to the power of 1 by 3 whole power r, that is r by 3. Okay, so these are the terms we are writing. So here 1 power p and 2 to the power of 1 by 2 whole power q, that is q by 2, and here 3 to the power of 1 by 3 whole power r, that is 3 power r by 3. Okay, now we are choosing this term is integral term. This term is integral term when the powers must be integers. Then the powers must be integers. Now we are choosing the values p, q, r. So we are taken the number of values for choosing p, q, r. So this is the general term. If you choose number of choices, that is the number of rational terms we are obtaining. Okay, now we are taken r is equal to 6. R is equal to 6. Then what is here? P is equal to 6. We are taken p is equal to 6. So the sum of the values of p plus q plus r is equal to 6. Here taken r p is equal to 6. Then the remaining terms were taken zeros only. So q by 2 and r by 3, 0 by 3 and 2 0 by 2 both are zeros. Okay, this is one chance. This is one chance. That is one integral term or one rational term. Then next we are taken this is 0. Then this is q is equal to 6. So that is 6 by 2. That is 3. It is integer term. So here we are taken 0. So the sum must be 6. Next 0, 0, 6. This is also 6 is divided by 3. The power is integer here. Taken r is equal to 6 and p and q are zeros. Okay. Next chance we have taken that is p is equal to 2. P is equal to 2. Okay. P is equal to and q is equal to 4. And q is equal to 4. Then what is here where p is equal to and q is equal to 4. So 4 by 2 that is integer. Okay. If you choose q is equal to 4 that is integer. And p is 1 to the power of anything is 1. So this is will be we are taken say 0. So 2, 4, 0 that is another chance. So these are the 3, 4 chances. And next other combination we are taken 3. If you have taken this is 3. If you take p is equal to 3, then what is q? Q is not taken 3. If you taken 3, this is not integer. This will be taken 0. So that is 0. Here r is equal to 3. If r is equal to 3, that is 3 by 3. That is integer. We are taken here 0, 3, 0. That is one chance. Okay. Next other chance. We are taken p plus q plus this must be equal to 6. 3 plus 3 that is 6. Next we are taken this is 4. This value is 4. Then what is the value? Here only 2. So 2 is 2 by 2 is that is integer. So this will be 0. Okay. 4 plus 2 that is 6. This is another chance. Okay. Next these are 3 plus 3 that is 6 chances. Next whatever another chance. If you take 1, p is equal to 1, that is 1 power 1, that is integer. Now we have taken this is that is 2 or 1, that is 2, only 2. If you take 2, then 2 by 2 that is 1. So this is 3 plus 1 plus 2 that is 3. If you take here r value is 3. We are taken r is equal to 3. So that then only we are getting here 3 by 3 that is integer, r is in, and 2 by 2 that is also integer. P is we are taken 1. 3 plus 3 it is also 6. These are the chances only. So remaining we are taken there is no another combination for the conditions p plus q plus is equal to r, and in that the powers must be integers. So powers here q by 2 must be integer and r by 3 is also must be integers. How many terms here? 1, 2, 3, 4, 5, 6, 7. So these total number of rational terms is 6. Therefore, the number of rational terms, in this expansion is equal to 7. These are 7 chances for the powers must be integers and also satisfies p plus q plus r is equal to 6. So the number of chances for the satisfying these two conditions only 7 chances. So the total number of rational terms in that expansion is 7. So the number of rational terms is 7. Okay. See the another problem. The number of terms free from radical sign in the expansion of 1 plus 3 power 1 by 3 plus 7 power 1 by 7 whole to the power of 10. In that expansion, the number of integral terms. Okay, that is nothing but free from radical sign. Okay, so what is the given expression here? That is 1 plus 3 to the power of 1 by 3 plus 7 to the power of 1 by 7 whole to the power of 10. Now we are writing in previous problem same formula, that is n factorial, that is the general term. The general term, what is the general term? Is 10 factorial by here p factorial, q factorial, r factorial. First term 1 to the power of p, second term that is 3 to the power of 1 by 3 whole power q, that is q by 3, and the third term is 7 power 1 by 7 whole power r by 7. Okay, now here p plus q plus here p plus q plus r is equal to 10. So the total index is here 10. The total of these values p plus q plus r is equal to 10. Now we are choosing the chances here. Taken p, q, r. What are the values we have taken? P, q, r. For these powers r must be integers. Here q by 3 and r by 7 must be integers. Then only the term is integral term. Okay, now we have chosen p is equal to 10. Then q is equal to 0 and r is equal to 0. So here q and r is 0, then these are 0 by 3 0, r by 0 by 7 is 0. Here p is 1 power 10, that is nothing but 10. P plus q plus r is equal to 10. Okay, this is one chance. Next we have taken the another chances. This is 0, this is 7, 3 and this is 7. So 3 plus 7, that is 10. 3 plus and okay, 0 plus 3 plus 7 is, that is 10. Here 3 by 3 it is integer, and here 7 by 7 is also integer. Now we have taken here 3 0 7 and okay, this is 0, this is 3 and this is 7, and this is 0, this is okay, it is already right. Then we are taken this is 7. Okay, this is we are taken 7. This value is 7. This value is 3. This value is 3. This value is 0. 3 by 3. This is 0 by 7. That is. So these are the three chances. Okay. Next we are taken 7. So this is 3. We are taken. This one is 3. Okay. This one is 3. These are the 4 chances. Then we are taken this is 4 and this is 6. Here 1 to the power of 4 is 1, that is here 3 power 6 by 3, that is 2, it is entered. This is we are taken 0. So 6 plus 4, that is 10. This is another chance, and one more chance is here 1, here 9. So 1 plus 9 is 10. We have taken this is 0. Here 9 by 3, that is also divisible. 9 is divisible by 3. Okay, this is the another chances. So these are the total chances for satisfies these conditions. P plus q plus r is equal to 10, and here p and q by 3 and r by 7 are integers. Okay, so how many chances here? 1 2 3 4 5 6. These are the 6 terms are integral terms, are free from radical sign. So therefore the number of terms free from radical sign. Okay, so total number of terms is equal to 6. So these are the 6 terms. Answer is 6. Okay.